In 2014, the Food and Agriculture Office of the United Nations came out with a report that said that considering the rate at which our current methods of agriculture are degrading the world's soils, we only have 60 harvests left. Now, here we are in 2025. We haven't changed our methods. We haven't come up with a solution to this particular problem. So, we're looking at just 49 years until we are no longer able to feed humanity. But what if I told you that urban agriculture has the potential to solve this particular problem? Hi, welcome to the Leader Innovations channel. My name is Edmund Williams, and today we're going to be talking about topsoil, in particular a component of topsoil called glomalin. So when we talk about soil degradation, what's being degraded? It's actually the topsoil loss. As we till the soil, erosion is certainly a problem, but the tillage and the fertilizer use and some of those other methods of industrial agriculture are really destroying the topsoil and turning it back into soil. So what's the difference? What makes topsoil topsoil? The difference is a component of the soil called stable soil carbon. And there's a lot of different components in that stable soil carbon. Some of them are dead microorganisms, some of them are various chemical components. But right now I want to focus on the largest single piece of that stable soil carbon, and that's a compound called glomalin. So glomalin is a soil glue. It has a bunch of different functions in the soil structure. It cycles nitrogen for the plants. It glues the soil particles together to create kind of a crumbly texture in the soil that's called tilth. It opens up the pores in the soil so that water can soak in. Once that water is soaked in, it actually helps the soil hold more water. It not only helps absorption, but it really actually helps the holding capacity, the carrying capacity of the soil for holding that water. So it increases drought tolerance. It also increases salt tolerance. It binds heavy metals. There's just a whole bunch of different pieces that it does. The creation of the soil structure creates habitat for the soil microorganisms that are so important to growing the plants that feed us. So what is glomalin? Why is it going away? Where does it come from? Glomalin is only produced on the roots of living plants by a symbiotic fungus family called mycorrhizal fungus. So the mycorrhizal fungus goes out and it finds nutrients in the soil and it brings them back and it trades them to those plants for sugars. And it glues those connections together with the glomalin. It uses it for some other stuff too, but that's one of the big pieces. And as that glomalin is created and it sloughs off into the soil, it pills up around the soil particles and creates that soil structure. Once it's in the soil, the glomalin lasts typically about 40 years. They've run carbon tests on it to determine that sometimes it doesn't last quite as long, but it certainly lasts up to 40 years, possibly longer. So the problem with the glomalin is that when you disturb the soil and you till it, you're kind of activating the nutrients, and one of the things that they start to use as a food source is that glomalin. So it's the tilling destroys the glomalin. More importantly, it destroys the processes that are making it. So it shuts down the production, and then what we have slowly starts to degrade. Unfortunately, we do not have any substitutes for it. There's nothing else that we've got that will serve the same function in the soil. We know how to make it in that we create the healthy conditions for plants, but it can take 100 years or more to bring the soil through natural processes back up to that basic amount. So what is the amount that we're looking for? So in a typical high carbon soil, you're going to see about 0.6% glomalin. There was a study several years ago that went all over California. The highest content that they found anywhere in California was 4.5%. The highest content they found anywhere in the world so far is 10%, and that was in Maui. So it's something that is, again, really, really powerful in very small amounts. But considering the slowness with which it's made, it can't be sustainably harvested. There's no way to, it doesn't ever build up to these huge amounts in the soil. And I really think that if we were able to create a way to make that glomalin in a way that it can be reapplied to the soil, we could potentially push some of those deadlines out and help our food production. And it just so turns out that Lear Soil Amplifier contains glomalin. Now, the reason that this happens is that the Lear Soil Amplifier is created under the roots of living plants. We inoculate it with mycorrhizal fungus, and that fungus gets in there and it's really, really active. But it does something a little bit weird. Like I said, it can take 100 years to make 0.6%. In a Lear garden, it happens in about 9 months. It'll make about 2%, and I've had it as high as 6.5%. And I think there's certainly some opportunities to sort of tune that creation mechanism, because I think we could even get higher than that. But even at 2%. In a year or under a year, we're still literally making glomalin hundreds of times faster than the natural systems can do that. Now, of course, one of the advantages of various forms of regenerative agriculture is that they have the ability to take that 100 years and knock it down to 2 or 3 decades. But that's still not fast enough to be able to fix this particular problem. So I think there's definitely a lot more research that needs to be done, but I think there's a ton of opportunity as we continue to bump up our production of the Lear Soil Amplifier, and using that to start replacing some of the glomalin in our degraded soil. So stay tuned. We're definitely going to keep working on this particular issue, and I think we're going to have some pretty exciting things to come.